He lies beneath a black canvas pricked with frost-white points, and the Milky Way lifts like a pale river from horizon to horizon. The air slows. A hush gathers that belongs to distances too large for worry. The band is ordinary starlight, scattered through dust, yet it feels like the inside of a seashell placed against the ear. He cannot hear the ocean, only the quiet logic of a galaxy that has learned to be gentle. This is not a storm of suns. It is an immense congregation that keeps its own cadence, a long exhale in the dark. The mind softens and the chest eases, as if the night practiced a lullaby for the small and the wakeful. The beauty is not fevered, it is sustained. It is a calm that took billions of years to perfect, and it is patient enough to share. The river he watches is a disk 100,000 light-years across, thinner than a cloud compared to its width, a lantern wheel of stars that turns without hurry. A full rotation takes roughly 200 million years. Nothing in that sentence is urgent. The spiral arms are not whirlpools dragging everything down. They are patterns in a traffic flow, density ripples where stars and gas linger briefly before moving on. The arms are quiet corridors, self-maintaining, more choreography than chase. The fact is simple and soothing. Motion at that scale can make a shape and keep it without crashing the dancers. Star to star, the neighborhood is spacious. If the sun were a coin, the nearest star would be another coin, several thousand kilometers away. In real units, the average gap in the stellar suburbs is a few light-years, a kindness of distance that lets gravity pull without catastrophe. The night sky looks crowded because the eye stacks perspective into a glowing braid, yet the reality is open, like a field with far-scattered trees. This sparseness is a peaceful fact. It says that calm can be the result of generosity in spacing. It says that an abundance of room can allow everything to travel safely. The galaxy's heart, hidden beneath curtains of dust, contains a supermassive black hole about 4 million times the mass of the Sunday. He imagines danger there, a furnace that devours. Then he learns that it is quiet by current standards. The black hole is not feeding ravenously at this moment in cosmic time. It naps between modest meals, and the region around it does not rage with the brightest kind of quasar light. In the present era, the center glows in radio and infrared tones, a hearth muted by distance and dust, leaving the broader disk in comparative peace. The calm spreads outward like a slow pulse. The sun lives far from the crowded core, about 27,000 light-years away, circling at a temperate speed with a multitude of other stars. This location is one reason for the night's serenity. There are fewer explosions nearby, fewer giant stellar clusters whose winds might strip atmospheres, fewer ardent giants shining with deadly radiation. He recognizes a tender truth. Safety can be a coordinate. A home can be defined by how softly the surrounding space moves. Starbirth in this galaxy proceeds with restraint. On average, 1 or 2 suns worth of new stars light up each year across the vast disk. The process is not a wildfire. It is more like rainfall on a large watershed, scattered and seasonal, governed by turbulence, that eventually yields to gravity, then moderated by the feedback from newborn stars. Heat and winds from the young clear the cradle, halting the collapse and preventing a rash of overcrowding. The result is a rhythm that never fully stops and never overreaches. Creation here understands pacing. Dark matter, unseen yet manifest in the galaxy's measured rotation, gathers like a wide cocoon. He cannot touch it, he cannot see it. He can only infer that a halo of mass extends far beyond the visible disk. This halo holds the outer stars in loyal motion, keeping the spiral from unraveling. It is a silent scaffolding, a peacekeeper with no face, present through its influence rather than its display. The knowledge that the unseen can stabilize the seen feels restful. The night teaches a strange lesson. Not every guardian must be visible. Magnetic fields thread the interstellar medium with delicate lines, weak enough to escape casual notice, strong enough to guide charged particles and shape the glow of diffuse gas. He considers these fields like harp strings stretched across a grand instrument. The music is not audible, but the pattern is there. Cosmic rays surf along these lines, and the gas avoids chaos by honoring invisible guidance. The idea comforts. Quiet does not mean absence of structure. It can mean a hidden order that asks for attention rather than applause. Even the dust that dims the stars is a gift. Those grains scatter the harsh glare, sculpting the Milky Way into mottled lanes and soft veils. They are remnants of old stars, atoms that once burned in fierce furnaces, now cooled into fine smoke. In blocking light, they allow twilight gradients and dark nebulae that invite the eye to linger. He finds peace in this bargain. What obscures also protects. What softens also reveals texture. The sky is not a flat blanket. It is a layered quilt with seams that tell a story. The sun's neighborhood floats inside a cavity of rarefied gas called the local bubble, the aftermath of ancient supernovae that cleared a volume and left the interstellar medium thinner than average. This bubble gives the stars around him a cleaner window, a clarity that enhances the soft luminosity of the band. It is a calm that arrived after storms long past. He takes the hint. Tranquility sometimes follows repair. The quiet he senses was earned by the medium itself, which learned to settle after being stirred. At the edges of sight, globular clusters form glittering beehives around the halo, their orbits long and serene, their stars old and patient. These ancient congregations twinkle like villages perched on distant hills. They do not shout, they endure. Their ages speak not of urgency but of longevity, a long peace that can be counted in half the age of the universe. He imagines their cores as libraries of stellar memory, packed and luminous, and still they hold their shape with courtesy. The galaxy is not perfectly still. Supernovae still bloom. Clouds collide and collapse. Small galaxies approach and are peeled into streams, yet the grand sum reads as composure. Tides distribute energy. Collisions are spread across incomprehensible distances and times. He lets this scale wash over him and notices how much human anxiety comes from cramped horizons. The Milky Way writes a counter-argument across the sky. Give motion time and room, and it can become melody. The color of the galaxy's light tends toward warm whites and gentle blues, the blended spectrum of billions of stars, most of them modest and long-lived. Blue giants mark youth, but they are few and brief. Orange and yellow suns dominate the tally, slow burners that prefer stability. He rests in this census. Peace can be statistical. Serenity can be the average of many quiet contributors, rather than the command of a few loud ones. The curve of starlight in the night is a demographic lullaby. He breathes with the turning of the earth. The river of stars shifts slightly as the planet rotates, a reminder that the calm above is never static. The galaxy's balance is dynamic, a supported motion, not a frozen sheet. Once more the lesson arrives, patient and clear. Calm is not the absence of movement. It is movement that has learned to agree with itself. It is a billion negotiations resolved into a path. He closes his eyes and sees that pale band as an invitation. If a mind needs evidence that the universe can cradle rather than crush, there it is, in a ribbon of milk across the dark. The facts are not merely facts, they are assurances. A large structure can remain coherent without tyranny. Gentle processes can win over violent ones when measured by vast time. Empty space can be a kindness. The center can rest. The edges can hold. When he opens his eyes again, the same galaxy remains, patient as ever, untroubled by his gaze. There is a wordless consent that passes from it to him. Sleep is allowed. The mind can fall like a leaf and be caught by the currents of starlight. The Milky Way does not demand attention. It offers it, softly, like water in a cup. He drinks, and the night becomes a room with a lamp left on in the hall, warm enough to feel safe, dim enough to welcome rest. The river of stars continues its long, quiet drift, and he goes with it, lighter than thought, steady as the turning wheel. In the cold air of the 18th century, astronomers lifted crude lenses toward a night they could not yet explain. The Milky Way appeared to them as a luminous fog, a smudge that crossed the sky with a stubborn grace. To the naked eye, it seemed like vapor, but through a telescope, it dissolved into countless points. The first realization struck quietly. The cloudy ribbon was not mist, but multitudes. Every speck was a Sunday. The immensity was not theoretical, it was visible, dense, and humbling. Humanity had found itself surrounded, yet did not know the architecture of its own home. William Herschel began the mapping with patience measured in candlelight. Night after night, he counted stars in every direction, noting where the numbers thickened and where they thinned. He imagined the galaxy as a disk of stars, the sun placed somewhere within. His counts were not perfect, but they whispered of a structure wider than any terrestrial map could suggest. What emerged was a sketch of a flattened island of light. It was a beginning, fragile and sincere, a first attempt to draw the unseen from within it. The wonder was not in accuracy, but in daring to measure the infinite. The 19th century brought refinements. As telescopes grew, observers discovered dark patches cutting through the bright band. Some thought they were holes in the star field, others suspected cosmic clouds. Their mystery deepened the beauty of the night. These shadows, it turned out, were dust lanes, curtains of material that blocked starlight and hinted at depth. The Milky Way was not a simple sheet, but a layered structure with folds and veils. The revelation changed how the galaxy was imagined. Not a flat picture, but a living dimension, textured and breathing. At the dawn of the 20th century, the Dutch astronomer Jacobus Kapteyn tried to chart the galaxy using the movements and brightness of stars. He produced a model shaped like a lens, about 30,000 light-years wide, centered roughly near the sunday. He called it the Kapteyn universe, a term both humble and bold. It suggested that the Milky Way was the entire cosmos. The universe, as far as science knew then, ended at the galaxy's edge. The night sky was a single city of light, floating in a void, its architecture still hidden but sensed through the faint whispers of mathematics. New instruments sharpened perception. Photography replaced sketches, allowing time itself to gather light. Long exposures revealed spirals and ellipses scattered beyond the Milky Way, ghostly shapes that challenged its monopoly on the cosmos. Some astronomers suspected that these nebulae were separate island universes. Others resisted the idea, clinging to the comfort of one galaxy. The question became a quiet duel between scales. Was the Milky Way everything, or merely one among countless others? The eventual answer would both shrink and elevate humanity, but for now, the Milky Way remained the grand stage, serene and unchallenged. As scientists measured distances using Cepheid variable stars, stellar beacons that pulsed with reliable rhythms, they began to sense that space extended far beyond previous boundaries. The discovery that light could be used as a ruler transformed the way the Milky Way was viewed. It was no longer an abstract glow, but a measurable structure. The rhythm of these stars provided a cosmic heartbeat, marking the tempo of distance, revealing that the galaxy was vast yet not infinite. It gave scale to the quiet that had once been only imagined. Dust and gas emerged as subjects of study, not nuisances. Spectroscopy, the reading of light as a language of lines, revealed the composition of interstellar clouds. Hydrogen, carbon, and oxygen spoke through absorption features etched in starlight. The Milky Way was found to be more than a star field. It was a tapestry of elements, a system that recycled its own matter. The notion of a static heaven dissolved. The galaxy became an ecosystem of birth and decay, a peaceful machinery operating with astonishing balance. Even destruction was part of its design, feeding future generations of stars with the ashes of the old. In the middle of the 20th century, radio astronomy offered ears to hear what eyes could not see. Cold hydrogen emitted at a wavelength invisible to the human eye, and its signal traced the spiral arms across the sky. The Milky Way's skeleton was drawn not in light but in sound, in gentle waves that travelled through darkness. For the first time, the hidden structure revealed itself as a grand spiral with a bar at its centre. The beauty was no longer speculative. It was mapped, measured, and still serene. The realization carried both awe and peace. The galaxy was an ordered swirl, not chaos. As measurements improved, the sun was found not to occupy the center, but to live in one of the outer arms. This repositioning shifted perspective. The human home was not the heart of creation, but a quiet suburb. The humility of that discovery did not diminish the grandeur, it enhanced it. To be in the outskirts meant to have space to observe, time to evolve, safety from the core's intensity. The discovery that the Milky Way's calmness was partly geographical added a layer of gratitude to cosmic understanding. Infrared observations pierced the dusty core, revealing hidden stars and glowing gas that human eyes could never perceive. The galactic center, once opaque, became a landscape of radiant knots and swirling matter. Each observation expanded the known boundaries of serenity. Even the dense heart showed patterns of equilibrium, circular orbits, and long-lived clusters. The universe appeared less as a battlefield and more as a choreography governed by subtle laws. Modern mapping, through satellites and data from millions of stars, now renders the Milky Way as a living structure in motion. Every star's position and velocity can be traced, turning the galaxy into a dynamic sculpture. The peace that viewers once sensed as stillness is, in truth, a harmony of movement. Each component, from stars to gas to dust, participates in a balanced exchange. The galactic disk endures not by resisting change but by absorbing it gracefully. Looking up tonight, anyone can share a feeling that took centuries to name as belonging. The faint arch in the sky is both map and memory, the residue of countless observations stitched into a vision of home. Every discovery that refined its image also softened its mystery, revealing that peace can emerge from precision. The more the galaxy was known, the more tranquil it seemed, as if clarity itself was a form of calm. The Milky Way, once a mythic path for gods and spirits, became the first evidence that order exists on a cosmic scale. Its discovery was not a conquest, but a listening. Through lenses, through glass, through radio and math, humanity learned that its home was neither chaotic nor cold. It was vast, structured, and tenderly balanced. Each generation added a layer of understanding, and each layer carried the same quiet truth. The galaxy is both motion and rest, both discovery and solace. The night remains the teacher, and the stars remain patient. The sky looks tranquil, yet its stillness is a clever disguise. Beneath that quiet band of starlight, every particle is in motion. The Milky Way is not a resting arch. It is a wheel turning with unimaginable speed. The sun, the Earth, and everything familiar move around the galactic center at nearly 220 kilometers each second. In one heartbeat, the planet travels farther than a jet plane could in hours. This velocity should make the galaxy roar, but it does not. Space is vast enough that even the swiftest motion seems silent. What appears peaceful is, in truth, a symphony of speed played on strings too long for human ears to hear. When astronomers first measured this motion, the results unsettled them. The stars that looked fixed were not fixed at all. They circled, tilted, and drifted in complex patterns, yet the whole disk held together as though governed by a single calm conductor. Nothing in Newton's equations alone could explain such poise. If gravity worked only by the visible mass of stars, the outer regions should fly apart, unable to keep up with the inner ones. But the galaxy did not unravel. The outer stars moved faster than expected, defying the simple logic of their distances. This defiance was not loud, it was steady, consistent, and mysterious. The Milky Way's serenity was hiding an invisible force. The discovery of galactic rotation was both marvel and shock. It proved that the Milky Way was a dynamic structure, not a frozen constellation. The revelation turned the quiet band into an ocean of orbiting suns. Imagine billions of trajectories intertwined, each star tracing an elliptical path that will never repeat exactly, yet somehow the whole shape remains constant. The spiral arms stay curved, the disk keeps its form, the night's beauty persists. To the human mind, it seemed improbable that such restless movement could preserve grace. The shock came from realizing that chaos, on a galactic scale, produces equilibrium rather than disorder. The more scientists observed, the stranger the motion became. At the edges of the galaxy, where gravity should weaken, stars raced with nearly the same speed as those near the center. The physics did not add up. If the mass of the Milky Way were limited to its visible stars and gas, those outer orbits would not hold. The galaxy would be torn apart. Yet it held, serene and unbroken. The calm glow of the night was maintained by something unseen, a dark mass that wrapped the galaxy in an invisible halo. This realization introduced one of the most haunting ideas in modern science. Most of the Milky Way's substance is invisible. The peace of the galaxy depends on a shadow. Even within the bright disk, contradictions piled up. Gas clouds, light enough to drift freely, moved in coordination with stars that should have ignored them. Spiral arms regions of higher density did not spin away or collapse. They persisted, turning slowly, as if the galaxy knew how to renew its own structure. The explanation came from the idea of density waves, regions where matter crowds together temporarily, like cars clustering briefly on a busy highway. Stars and gas flow in and out of these waves, creating the illusion of solid arms that endure. The galaxy behaves like a traffic pattern made of light, motion without collision, structure without rigidity. What disturbed early astronomers was the sheer order of it all. In a universe where entropy is supposed to increase, the Milky Way seemed to do the opposite. It sustained rhythm and balance across billions of years. Star formation, rotation, collapse, and renewal all coexisted without chaos overwhelming the pattern. The shock was not just scientific, but philosophical. If everything moves, why does the whole not disintegrate? The answer, still incomplete, hinted at deep coherence in nature, laws that favor continuity over collapse, a universe capable of patience. In the mid-20th century, the measurement of radio signals from hydrogen mapped this hidden rotation in exquisite detail. When plotted, the velocities drew a curve that refused to fall with distance. That stubborn flatness confirmed what had been suspected. Something vast and invisible bound the stars together. The Milky Way's calmness depended on mass that did not shine. Dark matter was named not for its color but for its silence, an unseen presence that tethers the luminous to the stable. Without it, the galaxy's peace would shatter. The gentle band in the night owes its endurance to what the eye can never see. This revelation carried both wonder and unease. The same universe that looked so serene was built upon mysteries deeper than darkness itself. Light traced only a fraction of truth. The Milky Way became a monument to unseen order. Scientists began to speak of gravitational halos, of particles that might pass through Earth in countless streams, unnoticed yet indispensable. The calm sky was a surface expression of a storm held in perfect balance by invisible laws. The thought made the galaxy feel even more profound. Stillness, it seemed, was an achievement, not a given. The shock deepened when astronomers realized how immense the system truly was. The Sun's orbit around the galactic center would take over 200 million years to complete, a single loop lasting longer than the age of mammals on Earth. Every sunrise and sunset happens within that journey. The mind staggers under the timescale, yet the pattern endures. Nothing in daily life hints that we are part of such motion. The night seems unchanged, the constellations familiar, though everything within them is gliding. The peace of the sky is a result of distance and duration, the smoothing of motion across time too vast to disturb perception. The Milky Way became the quiet evidence of a violent birth. Its stars were forged in collapse, its structure sculpted by gravity's insistence, its balance preserved by dark matter's restraint. Yet the shock remains philosophical. In a realm ruled by motion, the galaxy achieves stillness not by stopping, but by agreeing with itself. Every star contributes to a collective order, every orbit a compromise between falling and fleeing. This is the hidden truth behind the gentle shimmer in the sky. Peace is not the absence of energy, but the mastery of it. The Milky Way has learned how to move without breaking its own symmetry. The scientists who uncovered this truth did not erase wonder, they deepened it. They saw that the beauty of the night was a mask for an intricate dynamic harmony. Beneath the quiet glow lies an engine of colossal motion, powered by gravity, moderated by distance, wrapped in mystery. The galaxy's calm is not ignorance but wisdom, a balance refined through billions of years. To gaze upon it is to witness not a frozen picture, but the slow heartbeat of a system that has found its peace through perpetual motion. The light that reaches the night sky carries the stories of stars long gone. When astronomers began to peel back those stories through observation, they discovered that the Milky Way was not a flat wheel of quiet light, but a complex architecture of patterns within patterns. Each wavelength of light revealed a different layer of truth. In optical images, the spiral arms shone like brushed silk. In radio frequencies, they turned into streams of hydrogen flowing across invisible routes. Infrared eyes exposed ribbons of dust and regions of hidden birth. X-rays revealed scars of ancient explosions and quiet remnants still glowing with heat. The deeper science looked, the more intricate the serenity became. What appeared simple was in fact an orchestra of cycles and balances, a calm born from countless conversations between gravity and time. One of the first revelations from deeper observation was that the Milky Way breathes. Clouds of gas expand and contract, forming loops and bubbles carved by the lives and deaths of stars. Supernovae sweep cavities through the interstellar medium, and then the gas cools and collapses again, forming new generations of suns. From a distance, the process looks peaceful, but each breath contains violent energy, balanced by vast space. The galaxy is self-renewing. Its calmness is not stasis, but a rhythm stretched across billions of years. The observation of these breathing motions showed that creation and destruction coexist so gracefully that they appear still. Deeper data revealed that the spiral arms are not fixed structures, but waves of density moving through the disk. These waves gather gas and dust like the tides of an invisible ocean, allowing stars to form where pressure peaks, then drift away as the wave moves on. This idea transformed understanding. The Milky Way's beauty was not frozen geometry, but a living motion. The arms persist without tearing apart, because they are patterns, not objects. Through radio mapping, scientists traced these arms to their sources, seeing that they extended much farther than human sight. Even at the galaxy's dim edges, where the light fades, the pattern continues gentle, patient, and consistent. Infrared surveys looked past the veils of dust that had once obscured the center. They revealed a hidden bar of stars crossing the heart of the galaxy, a structure that channels gas inward, feeding new star formation while maintaining balance in the inner regions. The bar rotates slowly, steering material like a cosmic rudder. It was a quiet engine, unseen until instruments could sense its warmth. Its discovery replaced the image of a static hub with one of dynamic control, a core that moderates itself. Within that region, stellar clusters orbit in tight harmony, forming orbits like pearls threaded around an invisible axis. Each moves in its own path, yet the collective behavior remains astonishingly stable. Spectroscopy turned the light of the Milky Way into a voice that could be read. In those thin lines and shifts, astronomers found signatures of movement, temperature, and composition. The deeper the analysis went, the clearer it became that the galaxy is layered with gradients, chemical richness near the center, simpler elements near the outskirts. This gradient told a story of slow evolution. Stars near the core have been born and reborn through many cycles, enriching the interstellar medium with heavy elements. Outward, the stars are younger, their chemistry purer. The galaxy thus holds both history and youth at once. Its calmness formed from diversity in time. It is an equilibrium of generations. Even the dark gaps that separate the arms proved significant. Between them lies interarm space regions, not of emptiness, but of recovery. There, gas rests, cools, and prepares for the next encounter with a spiral wave. This alternation between compression and release gives the Milky Way its stability. It is the galactic equivalent of a tide that never ceases, yet never floods. Observations from radio telescopes showed vast filaments of hydrogen drifting silently, the threads from which the arms themselves are woven. The deeper the study, the clearer the order became. At the edges of the disk, where the light thins into darkness, astronomers found a faint warp. The Milky Way's outer regions bend like the rim of a slow-turning record. This warp, seen in the neutral hydrogen gas, hinted at gravitational conversations with unseen companions, perhaps satellite galaxies, perhaps the dark halo itself. Instead of breaking the symmetry, the warp adds grace, like a gentle curve to a stretched fabric. The galaxy adjusts to disturbance with elegance, not resistance. This flexibility might be the secret of its long survival. The discovery of stellar streams added another layer of complexity. Faint rivers of stars trail across the sky, remnants of small galaxies consumed by the Milky Way's gravity. They move in silent arcs, leaving behind ghostly patterns of motion. Though they mark a history of collision, the overall harmony remains intact. The galaxy absorbs disruption the way an ocean absorbs rain. Each new addition becomes part of the larger rhythm. The deeper scientists looked, the more they realized that balance does not mean perfection, it means endurance through adaptation. High-energy telescopes later discovered faint gamma-ray and X-ray bubbles rising from the galactic center, extending tens of thousands of light-years above and below the plane. These structures, vast and ghostly, are relics of ancient activity, perhaps from starbursts, perhaps from the central black hole when it last awakened. Yet even this evidence of power appears serene at present. The bubbles expand slowly, their edges smooth and diffuse. They are the calm memory of a storm long settled. The galaxy wears its history softly, like ripples after a distant thunderclap. Data from space observatories such as Gaia refined the picture further, mapping the motions of over 1 billion stars. Each star's velocity and direction now form a living model of the Milky Way in motion. When viewed from this perspective, the galaxy behaves less like a machine and more like a living organism. Regions pulse, twist, and breathe, yet the whole remains in balance. The quiet observed from Earth is not ignorance, it is resolution. The chaos is organized into harmony by the simple pull of gravity and the patience of time. The deeper investigations revealed another truth. The Milky Way's calmness depends on scale. What looks tranquil from afar would, up close, appear turbulent, but step back far enough, and all the turbulence fades into pattern. The lesson is not confined to astronomy. Tranquility, it seems, is often a matter of distance, an understanding that broadens rather than resists. Every deeper view of the Milky Way has turned confusion into structure, revealing how energy can coexist with stillness. The data does not diminish the poetry of the night, it heightens it. The galaxy's peace is built from motion too complex to sense. Its quiet, a matter of perspective and proportion. To study it is to learn that stillness is not the absence of events, but their perfect alignment. In that alignment, the Milky Way continues to spin, a silent testament to how the universe finds balance even in perpetual motion. The deeper the instruments reached, the more the Milky Way began to resemble a puzzle with pieces that refused to stay still. Each discovery, instead of closing the story, opened a door to further wonder. The spiral arms, the bar at the core, the halo of dark matter, and the river of stars circling in measured silence all seemed to obey a hidden logic. Yet the closer astronomers examined this calm structure, the more subtle its disturbances became. The galaxy, it turned out, was not as tranquil as it appeared. Beneath the graceful form lived constant negotiation between order and drift. One of the first hints that peace might hide complexity came from the stars themselves. When scientists plotted the motions of thousands of stars in the disk, they found ripples, large, slow-moving waves that rolled through space like the memory of a passing wind. These oscillations suggested that the Milky Way's disk is not perfectly flat but slightly trembling. Some stars rise and fall above the galactic plane over millions of years, responding to past encounters with unseen objects. Perhaps a small galaxy passed through long ago, or a cloud of dark matter brushed the disk and left it ringing. Whatever the cause, the vibrations endure. The Milky Way hums quietly in gravitational tones, too deep for ears to hear. Another deepening mystery came from the galactic bar. Its rotation speed did not match predictions. The bar turns more slowly than some models allowed, as though restrained by something invisible. Scientists suspect that the surrounding dark matter exerts drag on it, stealing angular momentum, changing the galaxy's internal rhythm. Yet even this resistance seems deliberate, measured. The bar continues to rotate, feeding gas toward the center, maintaining equilibrium while losing energy, a cosmic act of controlled surrender. The contradiction is mesmerizing, a galaxy that adapts to friction without breaking stride. Further observations revealed flares in the outer disk, regions where the thin plane of stars fans outward like a skirt catching a light breeze. This flaring could not be explained by simple rotation. Some blamed gravitational nudges from neighboring dwarf galaxies, others the gentle breathing of the dark halo itself. These shapes are so faint that they can only be detected statistically through the aggregated motions of millions of stars, and yet their existence speaks of continual dialogue between the visible and invisible parts of the galaxy. The Milky Way is not a rigid structure, it is a living field, bending where pressure asks, stretching where gravity yields. The discovery of stellar streams, those long trails of stars stripped from smaller galaxies, added another voice to this growing chorus of unease. The streams crisscross the halo like filaments of light, testifying to ancient mergers. One of them, the Sagittarius stream, wraps around the Milky Way like a broken bracelet. Each orbit it completes adds new motion to the disk, new vibrations to the plane, new stars to the population. What should have been quiet isolation turned out to be interaction. The Milky Way's grace is constantly renewed through collision. The piece we see is the product of perpetual assimilation, a balance achieved not by stillness, but by generosity. Then came the realization that the galaxy's stars do not all share the same ancestry. Some groups orbit backward, against the dominant direction. Some move in thick layers above the main disk. These stars are fossils of swallowed galaxies, preserved within the Milky Way's structure. The halo holds these relics in orbits that intersect like threads in a tapestry. Each thread is a memory of violence, absorbed and softened. The spiral's calm expression hides a history of consumption. The beauty of the Milky Way is not innocence, it is reconciliation. At the heart of this deepening mystery lies the supermassive black hole. For years, astronomers believed it to be dormant, but infrared and radio observations showed that the space around it flickers. Clouds of gas occasionally fall inward, heating as they descend, releasing faint bursts of energy before vanishing beyond the horizon. The black hole's hunger is restrained, not absent. Its quietness is not weakness, but control. It devours at intervals, then rests. The surrounding stars trace orbits that appear stable, but are influenced by its invisible pull. The center of peace contains the potential for fury, and yet balance prevails. As instruments grew more sensitive, scientists found giant arcs of gas looping from the galactic plane, remnants of ancient outflows that may have been driven by the central black hole's earlier activity. These arcs stretch for tens of thousands of light years, faint and smooth, as if drawn with deliberate care. Their presence hints at cycles of awakening and sleep at the galaxy's heart. The stillness of the present moment could be a pause in a long rhythm of activity. The calm might not be permanent, it may simply be a breath between pulses. Another enigma emerged from the outermost stars. Some move faster than the galaxy's escape velocity, thrown outward by gravitational interactions in the core. These hypervelocity stars are rare but telling. They prove that beneath the measured order lies occasional eruption. The Milky Way, though patient, sometimes releases its own fragments into intergalactic space. Even in its calm, it knows how to let go. The galaxy's magnetic field also plays a subtle role in this unfolding complexity. Once thought chaotic, it turns out to form a coherent pattern that threads through the spiral arms and extends into the halo. Charged particles travel along these lines, creating currents that interact with gas and dust. These magnetic flows influence how stars form, how cosmic rays spread, and how turbulence settles. The field is weak, barely detectable, yet its structure is vast and steady. It acts like a hidden skeleton that shapes the flow of energy without disrupting the peace. With each new observation, the idea of the Milky Way as a perfect, frozen spiral faded further. What replaced it was richer, a self-adjusting, self-healing organism. Every disturbance triggers a response that restores balance. Every imbalance finds a rhythm. The mystery of the Milky Way is how it manages to preserve beauty through ceaseless change. The more scientists uncover, the more the serenity seems deliberate, a kind of galactic wisdom written in motion. The deepening mystery is not chaos but coherence. Beneath the tranquil face of the night lies a system that bends without breaking, oscillates without collapsing, and evolves without losing identity. The Milky Way may tremble, flare, and consume, but it never dissolves. Its peace is elastic, its calm active. The galaxy is not frozen perfection, it is living equilibrium. Each orbit, each merger, each flare contributes to a vast conversation about endurance. The night sky's stillness is the echo of that conversation, continuing quietly above the turning Earth. Every mystery, no matter how serene its disguise, invites explanation. Once the Milky Way revealed its contradictions, motion without chaos, structure without rigidity, scientists began to craft theories that could account for its enduring calm. They searched for patterns in its motions, for equations that could hold together so many forces without collapse. The galaxy had become a kind of cosmic paradox, dynamic, vast, and yet stable. To understand its peace, astronomers turned to the invisible architectures that govern gravity, time, and matter itself. The first great speculation was that of the spiral density wave. In the early 20th century, astronomers believed the spiral arms might be physical streams of stars winding outward, like whirlpools. But if that were true, the arms would have wound up tightly long ago, vanishing into the disk within a few rotations. Yet the spiral pattern remained. The solution, proposed decades later, was almost poetic in its simplicity. The arms were not permanent objects but waves of compression, slow undulations of gravity that moved through the disk and briefly gathered material before letting it go. The galaxy's structure was, therefore, not a frozen sculpture but a standing wave like the pattern left on a pond after a gentle breeze. The arms were music written in gravity. This theory carried a strange beauty. It meant that stars could be born inside a spiral arm, drift outward as they aged, and still contribute to the shape that guided their creation. The galaxy sustained its grace not by holding everything in place, but by letting everything move. Density waves turned motion into form, much as wind shapes dunes that never stay the same yet always look familiar. The calm of the Milky Way could thus arise from a principle of cooperation rather than command. Each star followed its own orbit, but their collective gravities created the illusion of stillness. The next great idea reached deeper into darkness. When astronomers noticed that the galaxy's outer stars moved faster than visible mass could explain, they faced a missing ingredient. Dark matter was proposed as the invisible glue holding everything together. It was not made of atoms, nor did it emit light, but its gravitational pull could be felt everywhere. This unseen halo envelops the Milky Way, extending far beyond its luminous disk. In this vision, the galaxy floats inside a massive cocoon of dark material that cradles it, stabilizes its rotation, and dampens disruption. Without this hidden mass, the outer regions would fly apart. The galaxy's serenity then might rest upon the invisible kindness of darkness itself. Theories about the nature of dark matter multiplied. Some imagined vast clouds of undiscovered particles, weakly interacting, silent, and ancient. Others suggested exotic possibilities, primordial black holes, hidden forces, or modifications to gravity itself. Whatever its essence, dark matter's existence offered a profound metaphor. The Milky Way's balance depends not on what shines, but on what does not. Peace, in this sense, arises from the unseen. The calm we witness in the night sky is anchored by a mystery still unsolved. Another speculation emerged about the central black hole, Sagittarius A*. Though quiet now, it might once have flared with radiant power, shaping the inner galaxy through past eruptions. Theory suggests that such outbursts can regulate their surroundings. When gas rushes inward and feeds the black hole, it releases energy that pushes other gas outward, preventing runaway growth. This feedback loop, fierce yet precise, ensures that the core neither starves nor consumes itself entirely. The process is violent in miniature, but harmonious in the whole. The galaxy thus maintains peace not by avoiding extremes, but by allowing each to temper the other. The role of magnetic fields added another thread to the tapestry. For decades, astronomers thought them too weak to matter, yet simulations showed that even faint magnetism could guide the flow of interstellar gas, shaping clouds and influencing star formation. Magnetic lines, woven through the disk, act like scaffolds, directing turbulence into organized patterns. Cosmic rays spiral along them, dispersing energy smoothly rather than explosively. The magnetic field behaves like a soft lattice stretched across the galaxy, a quiet mediator between gravity and motion. In this invisible framework lies another source of stability, one that asks nothing of visibility to be real. Then came the theory of galactic self-regulation. Observations showed that the Milky Way's rate of star formation remains remarkably steady over billions of years. Gas collapses to form new stars, supernovae explode and scatter heavy elements, and yet the overall balance persists. Scientists propose that feedback from massive stars acts like a thermostat. When star formation accelerates, stellar winds and radiation heat the surrounding gas, slowing further collapse. When it slows too much, The gas cools and falls inward again. The result is a self-correcting cycle that keeps the galaxy from both frenzy and dormancy. It is as if the Milky Way breathes at a pace it has learned to sustain. Another elegant hypothesis addressed the Milky Way's resilience to collisions. Instead of shattering when struck by smaller galaxies, it absorbs them. Its massive halo of dark matter cushions impacts, spreading the energy of infall across vast volumes. This mechanism allows the disk to flex rather than fracture, to integrate rather than resist. The galaxy grows through gentle assimilation, turning potential chaos into quiet renewal. Theorists describe it as a form of gravitational diplomacy, a system so large that even disruption becomes part of its order. In recent years, computer simulations have modeled galaxies forming from primordial gas, evolving through billions of years under the influence of dark matter and cosmic expansion. Many of these digital universes produce systems that resemble the Milky Way: thin, spiral, calm, and luminous. The match between theory and observation suggests that peace might be the natural outcome of cosmic evolution. Given time, gravity sculpts balance. The forces that once scattered atoms after the Big Bang eventually learn to orbit in harmony. The galaxy, then, is not an exception to cosmic turbulence, but its resolution. Speculation extends even further, into the fabric of space-time. Some physicists propose that the galaxy's persistence arises from deeper symmetries of the universe, where gravity's geometry naturally favors smooth rotation over disorder. Others imagine that the Milky Way's dark halo could be influenced by quantum fluctuations at vast scales, a whisper of the earliest moments of creation still shaping the present. These ideas drift at the edge of testable science, yet they share a theme. Order is not imposed, it emerges. The theories converge on one truth: the Milky Way's peace is earned. Every spiral arm, every stable orbit, every quiet night results from forces in delicate conversation. Gravity attracts, dark matter supports, feedback restrains, magnetism guides, and time softens. Together, they weave serenity from struggle. The galaxy's balance is not fragile, it is practiced, a discipline refined over billions of years. The more science explains, the more astonishing the calm becomes. At the center of the Milky Way lies a quiet paradox, a black hole that should be violent, yet chooses restraint. Sagittarius A*, as it is called, occupies the heart of the galaxy like a sleeping ember. It contains 4 million times the mass of the Sun, compressed into a space smaller than Mercury's orbit. Around it, stars whirl in swift, precise orbits, some completing a loop in less than 2 decades. Their dance reveals an invisible weight, an anchor that bends space itself. And yet, there is no blazing inferno, no quasar light tearing through the dark. The center of this luminous galaxy is ruled by silence. For decades, astronomers suspected there must be something colossal hidden behind the dust at the galactic core. Radio waves provided the first clue, a faint, compact signal pulsing steadily from the constellation of Sagittarius. It was not a star, nor a cluster, but something dense enough to distort light itself. When infrared telescopes later resolved the motions of nearby stars, the truth emerged. Each star traced an ellipse around an unseen mass, accelerating as if pulled by an invisible hand. The calculations left no doubt. Only a supermassive black hole could explain such motion. The center of the Milky Way was not empty. It was full of gravity. But unlike the raging black holes at the centers of other galaxies, Sagittarius A barely feeds. The gas that drifts near it rarely crosses the threshold. Some of it forms a hot, faint disk that glows in radio and X-ray light. Most of it simply flows past, heated but not devoured. The black hole's current appetite is small, so small that it radiates millions of times less energy than it could. This calm behavior is what makes the Milky Way's core special. The monster sleeps, and because it sleeps, the galaxy around it enjoys peace. Theorists describe this state as a low accretion phase. When gas falls inward, it spirals, compresses, and heats, releasing radiation. Yet the density of gas near Sagittarius A is so low that cooling cannot keep up with heating. The result is a puffed, turbulent atmosphere that prevents more material from falling in. The black hole effectively chokes its own food supply, regulating its growth. This self-limitation may be temporary or cyclical, but it has lasted long enough to let the Milky Way's disk evolve without interference. The calm light of the night sky owes much to this cosmic moderation. Surrounding Sagittarius A Times is a region of extreme elegance known as the Central Cluster. It holds thousands of stars packed within a few light years. Some of them are massive and young, luminous giants that should not exist so close to such gravity. Their presence challenges models of star formation. How did delicate stellar nurseries survive near a black hole's pull? One theory suggests that gas clouds can orbit the center in dense rings until pressure triggers collapse. Another proposes that stars form farther out and migrate inward. Either way, they persist, their orbits stable and clear, their radiation diffused through dust and gas. The core is both lethal and nurturing, a paradox that remains one of the galaxy's most intriguing puzzles. Infrared and radio studies have uncovered filaments near the galactic center, thin, luminous threads stretching dozens of light years. These structures align with the galaxy's magnetic field and may carry charged particles accelerated by the black hole's surroundings. They shimmer faintly, tracing invisible lines of force. The region around Sagittarius A Times becomes less like chaos and more like a cathedral of geometry, each filament an organ pipe resonating to unseen harmonies. Even here, where gravity is supreme, order persists. From time to time, the black hole stirs. Astronomers have observed sudden flares of infrared light, brightening and fading within minutes. These are likely caused by small clumps of gas heating as they spiral inward before being swallowed. Each flare is a heartbeat, a reminder that the giant is alive, aware of its sustenance, yet chooses sparing consumption. The light pulses quietly, as though the galaxy itself inhales and exhales through its core. Further away, in the halo above and below the disk, lie the immense Fermi bubble's vast lobes of high-energy gas, extending tens of thousands of light-years. They are relics of an earlier era when Sagittarius A Times was more active, expelling material in twin plumes. Though faint today, their outlines remain, smooth and symmetric, like smoke long settled after a fire. The Milky Way carries the memory of its own tempests in these ghostly shapes. Their persistence suggests that even when the galaxy erupted, it did so symmetrically, maintaining a strange poise in its power. Scientists now suspect that the calmness of the Milky Way's center is not accidental. It may represent a balanced phase between feeding and rest, a homeostasis achieved through feedback. When Sagittarius A Times consumes too much, it emits energy that drives gas away, starving itself. When it rests, gas drifts back, ready to feed again. Over billions of years, this balance has likely repeated many times, shaping the rhythm of star formation in the inner galaxy. The peace of the present may be the result of countless cycles of tension and release, a long dialogue between hunger and restraint. The study of Sagittarius A Times deepened with the Event Horizon Telescope, an Earth-sized network that captured the first image of a black hole's shadow. When directed at the Milky Way's heart, it revealed a faint ring of light encircling darkness, distorted by gravity's curve. The image was humble compared to the fury of distant quasars, but it was ours, a quiet eye at the center of our home. It confirmed what theory long suggested. Even at the edge of the unknowable, the Milky Way preserves grace. In the grand view, the black hole is both heart and anchor. Its gravity binds the galaxy's core, its quiet keeps the disk safe from turbulence, its restraint allows the spiral arms to endure. Without it, the Milky Way might lack coherence. With it, balance is possible. The calm night above every sleeper on Earth begins here, in the hush of a black hole that has learned how to wait. Theories continue to explore how long this peace might last. Sagittarius A Times could awaken again, as others of its kind have, shining with the energy of millions of suns. But even if that day comes, the scales of time are so vast that humanity would never witness the transition. The black hole's patience extends beyond epochs. For now, it is still, and in that stillness lies a kind of cosmic mercy. To gaze towards Sagittarius A Times is to look into the eye of quiet power. It is the still point of the turning world, a gravity that holds without crushing, a silence that radiates order. The Milky Way's most peaceful fact may be this: its greatest force is also its gentlest. In that paradox lies the secret of endurance, the reason the galaxy glows softly through the dark, serene in the care of its sleeping heart. Far from the violent heart, the Milky Way unfolds into gentler neighborhoods where sunlight drifts through thin veils of gas and dust, and the gravitational pull of the galactic core softens into a distant hum. This is where the Sun resides, roughly 27,000 light-years from the center, orbiting in the quiet outskirts of a spiral arm. Astronomers call this region the Orion Arm, a modest lane between two grander avenues of stars, neither too crowded nor too sparse. It is here, in this calm suburb of the galaxy, that the solar system circles like a small lantern in an immense and peaceful city. The Sun's neighborhood is far from random. It sits inside a pocket of unusually clear space known as the local bubble, a cavity carved by ancient supernovae that exploded millions of years ago. Those explosions once filled the region with shock waves, but time has smoothed their scars. What remains is a volume of rarefied gas, a kind of celestial clearing. Within it, the density of interstellar matter is lower than the galactic average, allowing light from distant stars to travel more freely. The night sky's sharp brilliance, the visible thread of the Milky Way itself, is in part a gift of this transparency. The very peace we see above is an echo of past violence, softened by age. The local bubble shelters the Sun within a warm, low-density zone, about 1,000 light-years across. Surrounding its edges are cool, dense clouds that mark the boundary with other interstellar regions. One of these neighboring zones connects to what astronomers call the Gould Belt, a tilted ring of young stars and molecular clouds that loops around the Sun's position. This structure hosts familiar constellations like Orion, Taurus, and Perseus, each a cluster of newborn suns still glowing with the heat of creation. The Sun happens to sit just between these active nurseries and the calmer, older populations of the galactic disk. It is a fortunate equilibrium, a location neither too lively nor too barren. In this tranquil environment, the solar system moves through the galaxy's thin disk like a small ship sailing across a shallow sea. The Sun completes one orbit around the Milky Way roughly every 230 million years. During that time, it gently bobs up and down through the galactic plane, rising and falling by a few hundred light-years, following the gravitational contours of the disk. These oscillations happen so slowly that an entire era of life on Earth passes in a single wave. Yet this motion keeps the solar system within a stable zone, far from the crowded inner regions where supernovae are common, and far from the empty halo where stars grow scarce. The calm we inherit from the night sky is a matter of celestial geography. The relative quiet of this location allows fragile things to survive. Planetary atmospheres, organic molecules, and delicate ecosystems could hardly endure in the galaxy's more tumultuous neighborhoods. Radiation near the core is intense. Shocks from frequent supernovae can sterilize space for light-years around. But here, the background radiation is low, and the nearest massive stars are distant enough to pose no threat. Earth's biosphere evolved under this gentle cosmic weather. In a sense, the calm of the Milky Way is written into the chemistry of life itself. Even the Sun's age fits this neighborhood. At 4.6 billion years old, it belongs to a middle generation old enough to have formed from enriched material, young enough to shine steadily. Its orbit is nearly circular, ensuring smooth passage through the galactic disk. Many stars follow more eccentric paths, venturing closer to the core or out toward the rim, but the Sun keeps to a well-behaved track. Astronomers sometimes describe this orbit as kinematically cold, meaning it lacks the erratic motions that heat and stir the stellar population. The galaxy's peace is mirrored in its paths, and our star follows one of the calmest routes available. The local bubble's boundaries are now being mapped in exquisite detail. Using data from the Gaia mission and radio observations of interstellar gas, scientists can trace its contours like a three-dimensional landscape. The result is a vision of gentle walls, arcs of denser material where supernova remnants once collided, now cooled into filaments of molecular clouds. These edges are places of quiet renewal, where new stars are born from the dust of the old. The Sun, drifting through the center, is both witness and beneficiary of this ancient recycling. The galaxy builds peace not by stillness but by perpetual transformation, refining chaos into harmony over eons. Beyond the local bubble, other cavities and shells overlap, forming a lacework of bubbles and filaments that stretch through the spiral arms. This network is sometimes called the galactic web, a frothy texture sculpted by stellar winds and explosions. Yet even this complexity leads to order. The bubbles regulate pressure, preventing any one region from collapsing uncontrollably. The interstellar medium, though restless on small scales, maintains overall balance. In the Orion Arm, where the Sun resides, these forces have reached an enduring compromise. The galaxy's peace is written into the geometry of its voids. From this serene vantage, the Milky Way's larger rhythms play out almost imperceptibly. The spiral arms drift, the bar at the center turns, and the halo quietly enfolds it all. The Sun's motion through the disk exposes Earth to changing cosmic environments, sometimes closer to dense clouds, sometimes farther into open space, but the transitions are slow, measured in millions of years. Each era of life on Earth unfolds within a slightly different backdrop of cosmic conditions, yet the shifts are smooth enough to allow continuity. The planet's long story has been told in the lull between stellar storms. The peacefulness of the solar neighborhood has also shaped human imagination. For millennia, when people looked upward, they saw constancy. The same constellations returned each season. The Milky Way's glow remained steady. This visual permanence became a symbol of endurance in every culture, a reassurance that something vast and unchanging hovered above the fleeting struggles of life below. Only modern astronomy reveals how deceptive that stillness is. Every star in those constellations moves through space at tens of kilometers per second, yet the distances are so vast that change unfolds too slowly for the human eye to notice. What appears eternal is motion spread thin across time. In the quiet arm of the Milky Way, the Sun will continue its long orbit for billions of years. It will pass through new regions of gas and dust, experience gentle shifts in stellar density, and perhaps one day drift out of the local bubble entirely. But for now, its path remains smooth and unhurried. The Earth spins beneath a canopy of light that has been curated by distance, balance, and luck. The peace of the galaxy is not an illusion. It is a gift of circumstance, a harmony that emerges when energy, gravity, and time agree. To sleep beneath the stars is to share this quiet orbit. Every breath taken on Earth belongs to a system moving through space with measured grace, shielded by an ancient bubble, guided by the galaxy's invisible symmetry. The Milky Way's calmest truths live here, in the Sun's serene suburb, a cosmic middle ground where existence is possible because the universe, for a while, chose gentleness. In the galaxy's quiet reaches, creation proceeds in moderation. The Milky Way's star-forming regions do not burn with reckless intensity. They hum like patient furnaces, balancing pressure, and collapse with exquisite care. Every glimmer in the spiral arms marks a nursery where gas and dust drift into denser knots, slowly gathering mass until gravity takes hold. Yet these regions rarely spiral into chaos. They form stars at a rate of only a few solar masses each year, a cosmic pace that feels unhurried, deliberate, almost meditative. This gentleness of creation is one of the galaxy's most peaceful facts, the understanding that even birth, in the cosmic sense, can be quiet. The raw material for these new stars lies in the molecular clouds that thread the arms. They are immense reservoirs of hydrogen and carbon, so cold that their temperatures barely rise above absolute zero. Within them, tiny fluctuations in density grow over time. Gravity begins its work imperceptibly, drawing atoms together until the gas warms and emits a soft infrared glow. Inside, small clusters of stars ignite, wrapped in cocoons of dust. To the eye, these nurseries are invisible, but radio telescopes trace their faint signatures. They appear not as eruptions but as slow awakenings, clouds folding inward, the universe exhaling light through the pores of darkness. What makes this process remarkable is its restraint. In galaxies more active than ours, star formation can rage uncontrollably. Massive stars ignite in great numbers, and their ultraviolet light strips surrounding gas bare, ending further formation in violent bursts. The Milky Way avoids this fate through balance. Its gas supply is steady but limited. Its spiral arms compress the medium gently, rather than violently. Feedback from young stars, winds, radiation, and supernovae acts as a self-regulating mechanism. When a cluster of newborn suns grows too energetic, it drives away the very gas that formed it, cooling the neighborhood, silencing further births. The galaxy breathes in cycles, alternating between creation and rest. This equilibrium gives rise to astonishing continuity. While individual stars are born and die in millions of years, the overall star formation rate has changed little for billions. The Milky Way is a model of long-term moderation. Its arms serve as both incubators and governors, ensuring that the process never tips into frenzy. Every new generation of stars joins an ancient rhythm, feeding the galactic ecosystem with heat, metals, and radiation, then yielding space for the next. The peace lies not in stillness, but in the constancy of the pattern. Within the Orion Arm, several of these nurseries shimmer faintly through dust. The Orion Nebula, the Carina Complex, and the Eagle Nebula, to name a few. They are laboratories of creation, places where physics becomes poetry. The Orion Nebula, visible even to the naked eye, glows with the light of newly formed stars sculpting the surrounding gas into curtains and pillars. Yet the violence of their birth feels softened by distance, their energy translated into luminous art. The Eagle Nebula's famous pillars of creation are columns of dense gas slowly evaporating under starlight, collapsing and dispersing simultaneously. The image captures a truth deeper than appearance. Creation and erosion are inseparable. The universe paints with both brushstrokes at once. Astronomers studying these regions often describe a cosmic tug-of-war between gravity and pressure. When gas collapses too quickly, feedback halts the process. When pressure dominates, gravity bides its time. The Milky Way's moderate rate of star formation suggests it has reached a sweet spot where both forces are in conversation rather than conflict. This balance may be why our galaxy has maintained a stable disk for billions of years. Too much activity would thicken the disk with turbulence, too little would starve it of light. Instead, the Milky Way sustains a slow, sustainable rhythm of renewal, a long exhale between heartbeats. The moderation extends to the types of stars born. The galaxy favors low-mass stars like the Sun, which live long, steady lives, over massive ones that burn fast and die young. This preference is encoded in the initial mass function, a distribution describing how many stars of each mass are formed. In the Milky Way, small stars outnumber giants by far. This bias ensures stability. Long-lived stars dominate the light, radiating gently for billions of years, while massive stars, though rare, seed the galaxy with heavy elements when they die. The coexistence of both kinds of stars is another form of peace. Endurance paired with renewal, patience paired with transformation. Supernovae, those brief flashes of stellar death, play their role in the quiet equilibrium. Each explosion releases vast energy, yet the galaxy absorbs the impact gracefully. The shockwaves sweep through nearby gas, stirring it but not shattering the overall order. These waves carve new cavities and ignite future star formation, continuing the cycle. The violence is local, but its effect is creative. Across immense timescales, the Milky Way converts destruction into preparation, building calm from the aftermath of flame. Even the chemical evolution of the galaxy tells a story of moderation. Early generations of stars forged the heavy elements that now color the interstellar medium. Each new cycle refines the balance of ingredients, allowing planets, atmospheres, and eventually life to emerge. The process advances slowly but surely, a gradual enrichment of possibility. This chemical patience mirrors the galaxy's dynamic patience. Neither happens quickly, yet both result in abundance. The Milky Way's peace is not a pause in time, but a trust in it. Theory suggests that our galaxy's steady star formation owes much to its stable supply of gas. While cosmic collisions often trigger starbursts in other systems, the Milky Way's encounters have been gentle. It draws in material from its surroundings through streams of hydrogen that drift inward at low density. These flows replenish the disk without flooding it, maintaining a steady equilibrium. The galaxy feeds without greed. Each infusion of gas is tempered, folded quietly into the ongoing process of creation. In the far future, billions of years from now, the supply of gas will dwindle. The Milky Way will slowly fade as star formation ceases, leaving behind a population of long-lived red dwarfs glowing faintly in the dark. Even this decline will happen gently, without drama. The galaxy will not die in fire, but in cooling light, settling into the same kind of peace it has always nurtured. The end will be a continuation of its nature, a slow dimming rather than a collapse. To understand star birth in the Milky Way is to witness cosmic restraint made visible. Every region of creation, every glowing nebula and cloud, participates in a choreography of moderation. The galaxy's tranquility is not an accident. It is a choice written into the laws of physics. Gravity and radiation, expansion and collapse all know their limits. From those limits emerges beauty. The Milky Way teaches that creation need not be hurried, that harmony is often the outcome of patience. Its stars are born not in fury but in balance. And through that balance, the night remains gentle enough for dreaming. There are forces in the Milky Way too subtle for the eye to trace, yet they shape everything the way wind shapes dunes. Among the most delicate and most essential are the magnetic fields that lace through the galaxy's disk and halo. They do not shine or cast shadow, but they weave a hidden order through the darkness, threading gas, dust, and plasma into quiet cohesion. These invisible lines of force are the galaxy's soft architecture, the lattice that allows calm to persist amid motion. They hold no color, yet they compose a cosmic lullaby, vibrating through space with a frequency beyond sound. Astronomers first discovered evidence of the Milky Way's magnetic field by studying polarized light starlight that had been subtly aligned as it passed through interstellar dust. This alignment hinted that the dust grains themselves were oriented by an unseen magnetic influence. Later, radio observations revealed synchrotron radiation, the faint glow of electrons spiraling along magnetic lines at near-light speeds. These clues confirmed that the galaxy is magnetized from end to end. Its field is weak, only a few microgauss, millions of times gentler than a refrigerator magnet, but it extends for tens of thousands of light years, coiling through the spiral arms like the veins of a vast organism. In the galactic disk, the magnetic field runs roughly parallel to the spiral arms, tracing their curvature with quiet fidelity. This alignment is not accidental. The differential rotation of the galaxy stretches and amplifies the field, a process called the dynamo effect. As the disk turns, turbulence in the interstellar medium twists the magnetic lines, regenerating them. The result is a self-sustaining system, one that maintains strength across eons. The field does not resist motion, it accompanies it, smoothing the flow of gas and reducing chaos. Where the field is strongest, turbulence fades, and clouds of gas coalesce with elegant precision. Magnetism plays a quiet but crucial role in star formation. Within molecular clouds, magnetic pressure counters gravity just enough to prevent premature collapse. Only when gravity overcomes this magnetic tension do the densest cores give birth to stars. Without that restraint, the clouds would fragment too quickly, igniting thousands of stars at once and burning through their fuel in a single galactic breath. Magnetism therefore acts as a kind of guardian, ensuring that creation proceeds with deliberation. It imposes patience on a process that might otherwise rush toward exhaustion. The Milky Way's peace owes part of its rhythm to these invisible threads. The field also guides cosmic rays, high-energy particles born from supernovae and other violent events. Instead of streaming straight outward, these particles spiral along magnetic lines, their paths bent into graceful curves. This diffusion spreads their energy evenly across the galaxy, preventing local catastrophes and allowing radiation levels to remain tolerable even near active regions. What could have been destructive becomes balanced, redistributed through invisible order. The same mechanism that tempers collapse in clouds also moderates violence in explosions. The field is the quiet intermediary between extremes. In the halo above and below the disk, the magnetic field becomes more chaotic, forming loops and arcs that connect to vast outflows of gas. These lines reach upward like filaments of mist, joining the galactic plane to its outer envelope. Some of them link directly to the Fermi bubbles, those immense lobes of high-energy plasma that rise from the center. The magnetism there appears twisted and braided, shaping the edges of the bubbles and guiding their expansion. Even in the aftermath of ancient storms, order reasserts itself. The galaxy seems incapable of forgetting its symmetry. Closer to the disk, the field interacts with dust and gas, to create structures of surprising beauty. Radio telescopes have imaged long, narrow filaments stretching hundreds of light years, glowing faintly in polarized light. These filaments follow the contours of the magnetic field, marking the otherwise invisible lines that cross the sky. Some run parallel to the spiral arms, others stand perpendicular, bridging layers of the interstellar medium. They resemble the harp strings of an unseen instrument plucked by cosmic winds. Through them, the galaxy hums imperceptibly, but perpetually. Magnetism also binds the small to the large. On planetary scales, it shields atmospheres. On stellar scales, it drives flares and winds. On galactic scales, it unites stars, gas, and plasma into a single, coherent medium. The Milky Way's field is thus both local and universal, a connective tissue that allows separate systems to communicate. It carries energy and momentum quietly across space, knitting the galaxy into continuity. If gravity provides the shape and motion, magnetism provides the texture, the softness that lets energy move without tearing the fabric. Theorists have suggested that these magnetic fields may have originated in the earliest epochs of the universe, long before galaxies formed. Tiny seed fields could have been amplified as matter condensed, growing stronger with each rotation of the disk. If so, the magnetic network of the Milky Way is a relic of creation itself, an echo of the primordial currents that once flowed through the newborn cosmos. Every field line that curves through space today may trace back to the dawn of time, surviving every collision, merger, and rebirth the galaxy has endured. The piece of the Milky Way is older than its stars. In numerical simulations, when scientists include magnetic fields, galaxies form with remarkable smoothness. Without them, turbulence dominates, disks thicken and shatter. The presence of magnetism reduces chaos, channeling motion into streams that persist for billions of years. It acts as a teacher of order, turning raw energy into structure. The Milky Way's calm, seen from this perspective, is not accidental but emergent, a property that arises naturally when invisible forces agree to cooperate. Perhaps the most haunting aspect of galactic magnetism is its silence. It cannot be photographed directly, cannot be felt or seen, yet it permeates everything. It is a whisper that shapes worlds, a ghostly geometry that lends form to light. The magnetic field holds no boundaries, only guidance. Like a gentle current beneath a still lake, it moves unseen but decisive, ensuring that what drifts above does so smoothly. To understand this invisible architecture is to glimpse the depth of the galaxy's harmony. The Milky Way's serenity is not the result of emptiness, but of invisible structure fields that discipline motion without restraining it. Each line of magnetism is an unwritten law, ensuring that chaos becomes rhythm and noise becomes pattern. Beneath the luminous arms and glowing clouds, these quiet lines weave an order so delicate that it can only be called peace. Across the vast span of the Milky Way, billions of stars trace their paths in quiet obedience to gravity. Yet their motion is not random. There are hidden corridors where orbits align, intersections where motion becomes harmony instead of collision. These are the resonances of the galaxy, the invisible geometry that keeps its dance from turning chaotic. Within this cosmic machinery, stars drift through safe harbors, regions where the pull of spiral arms, the turn of the bar, and the galaxy's rotation all balance with exquisite precision. The Milky Way's stillness, it turns out, is not inertia, but negotiation. Resonances arise wherever orbital periods relate to one another in simple ratios. A star whose revolution matches the pattern speed of the spiral arms, where it circles the galaxy in exactly the same time the arms revolve, enters a region called corrotation. There, the spiral pattern neither overtakes the star nor lags behind. It moves in synchrony, a perfect cosmic duet. In this zone, stars can travel for hundreds of millions of years without being tossed into new orbits. Gas clouds drifting through the corrotation circle experience gentle compression instead of shock, allowing star formation to proceed calmly. Astronomers suspect that the Sun itself lies near this tranquil lane, where the forces of the galaxy reach a soft compromise. Closer to the core, another kind of resonance operates the Lindblad resonances, where the oscillations of stars in their orbits synchronize with the rhythm of the spiral arms. These resonances act as boundaries that shape the structure of the disk. Inside them, orbits are more circular. Outside, they become elongated. The transitions between these regions mark where spiral arms rise and fall, giving the Milky Way its graceful curves. Though invisible, these resonances are like the tuning pegs of a stringed instrument, tightening or relaxing motion until harmony is achieved. The galactic bar introduces further complexity. Its slow rotation sets up additional resonances that trap stars in elongated orbits aligned with its shape. Instead of scattering them chaotically, these resonances organize the inner disk into steady flows of matter. Gas follows predictable paths, feeding the core without collapsing into it. Stars move in loops that keep the bar's structure intact. This self-sustaining geometry prevents turbulence from overwhelming the inner regions. The Milky Way, seen in this light, behaves like a resonant instrument whose parts vibrate together in silence. Even beyond the visible disk, resonance governs. The dark matter halo, though unseen, shapes the precession of stellar orbits, subtly adjusting their motion so that the galaxy remains dynamically balanced. Computer simulations reveal that when these harmonies are broken, when resonance patterns overlap or drift, the result is instability. The disk thickens, stars scatter, and spiral arms lose coherence. Yet the Milky Way resists this fate. Its resonances appear tuned to a remarkable equilibrium, each region supporting the next, each motion complementing its neighbor. The galaxy sustains itself by being in tune with itself. Resonances also explain why the Milky Way's spiral arms can persist for billions of years. Without them, differential rotation would twist the arms into oblivion. But at resonance zones, the pull of the pattern speed and the orbital motion lock together, preserving the shape. The arms are not fixed. They are maintained by these hidden pacts between gravity and time. Each resonance acts as a promise kept, ensuring continuity through change. The Sun's proximity to corrotation may be one reason for Earth's stability. Here, the spiral arms pass less frequently, reducing encounters with dense molecular clouds that could disturb the Oort cloud or send comets inward. The solar system's orbit threads through a region of lower density, a safe harbor in a sea of stars. Life on Earth, fragile as it is, benefits from this celestial geography. It exists in a zone of gravitational peace, an orbital sanctuary carved by resonance. Observations from the Gaia mission have revealed intricate patterns in the velocities of millions of stars. When plotted, they form ridges and wave signatures of resonance. Some appear to be the echoes of long-past encounters with satellite galaxies, which set the disk oscillating. Others align perfectly with predictions from the spiral and bar resonances. The galaxy's calm surface hides these internal harmonics, like ripples frozen in a pond. Each pattern is a record of the Milky Way adjusting itself, finding equilibrium after every disturbance. Astronomers now speak of phase mixing and secular evolution, terms that describe how stars redistribute their motion over time. Resonance acts as a mediator in this process, slowly blending chaotic energies into ordered structures. Over billions of years, this blending smooths the disk, preventing violent shifts. The Milky Way's longevity depends on this quiet conversation between stars and gravity, a dialogue so slow that no single generation of humanity could ever witness it complete. The poetry of resonance lies in its paradox. It is both constraint and liberation. It binds orbits to certain paths, yet by doing so, it ensures freedom from collision. It imposes order, yet that order allows diversity of motion. In the galaxy, harmony is not imposed by force but achieved through timing. Each star is a note in a symphony that never ends, playing its own line while keeping faith with the larger rhythm. These resonances extend their influence beyond mechanics. They reveal that peace, at the largest scales, is an emergent property of balance. Every orbit that stays stable, every cloud that forms a star without catastrophe, owes its serenity to alignment rather than stillness. The Milky Way's calmness is not the quiet of emptiness. It is the quiet of synchronization. The galaxy is not merely rotating, it is resonating. To imagine this is to see the night differently. Each star, each faint shimmer, participates in an ancient pattern, repeating ratios of motion and pause that hold the galaxy together. The Milky Way's elegance arises from these invisible harmonies, the same way a melody arises from silence arranged in order. Even the Earth, circling the Sun, drifts through one of these zones of grace. Every breath taken under the stars belongs to an orbit, and every orbit belongs to a rhythm. In that rhythm, peace finds permanence. Resonance teaches that the universe's stillness is not a pause, but a balance of movements agreeing on tempo. The Milky Way turns in infinite quiet because every part has learned to listen. Along the ragged outskirts of the Milky Way, the calm veil of the galaxy sometimes stirs. There, far beyond the familiar arms, small galaxies drift toward their larger host, drawn by its immense gravity. They arrive like distant travelers at the edge of a glowing city, fragile, curious, and doomed to merge. These are the satellites of the Milky Way, the Magellanic Clouds, the Sagittarius Dwarf, and other faint companions whose fates are written in slow tides. Their approach could have been violent, but it is not. The galaxy absorbs them gradually, turning what might have been collision into quiet inheritance. The large and small Magellanic Clouds, visible from the southern hemisphere as soft smudges of light, are the most prominent of these visitors. Each is a galaxy in its own right, trailing gas and stars as it orbits the Milky Way. Together they weave a luminous bridge across space, a stream of hydrogen that arcs like a ribbon between them and their host. This Magellanic stream stretches for hundreds of thousands of light years, a subtle mark of their surrender to the Milky Way's pull. It is not a scar but a thread of connection, a river feeding fresh material into the galactic disk. Through this gentle transfer, the Milky Way replenishes itself, using the remnants of smaller systems to renew its own substance. Other companions follow similar fates. The Sagittarius Dwarf Galaxy, discovered in the 1990 seconds, is being slowly shredded by tidal forces as it orbits the Milky Way's core. Its stars have been stripped into a long stream that wraps around the galaxy like a faint halo. What might seem destructive on human timescales is, in the language of billions of years, a seamless blending. The dwarf stars no longer belong to a separate system, they have joined the Milky Way's choir, their orbits folded into the larger harmony. The galaxy's serenity is not maintained by isolation, but by inclusion. These mergers are not rare. Astronomers believe that much of the Milky Way's halo, the sparse sphere of old stars surrounding the disk, is composed of the remains of long-absorbed galaxies. Each left behind its signature in the motions of the stars, a whisper of past arrival. Modern data from the Gaia mission has revealed dozens of such relics, stellar streams and clumps that trace the paths of vanished galaxies. They form ghostly trails across the sky, each the fossil of an encounter that ended not in explosion, but in union. The remarkable fact is how peacefully this process unfolds. When two galaxies meet, their stars rarely collide directly. The distances between them are so immense that even in a merger, most stars pass silently through. Gravity, not impact, does the work, stretching, pulling, and redistributing motion until the smaller body dissolves into the larger. The energy of encounter becomes the music of equilibrium. The Milky Way grows by gathering, not by conquest. Simulations suggest that the galaxy has undergone dozens of such mergers throughout its life, each one adding to its mass, enriching its elements, and expanding its halo. These ancient unions gave the Milky Way its thick disk and may have stirred the seeds of its spiral arms. Yet the overall balance endured. Instead of shattering, the galaxy learned to absorb impact like a dancer, pivoting with each push. Its calmness is not the absence of change, but mastery of it. The Magellanic Clouds may eventually share the same fate. Over the next few billion years, they will spiral closer, their orbits decaying under the pull of dark matter and tidal friction. Streams of gas will continue to pour into the Milky Way, fueling new generations of stars. One day, the clouds themselves will dissolve completely, their stars becoming indistinguishable from the galactic field. The Milky Way's edge will grow brighter for a time, then smooth again. Even this act of consumption will end in balance. Astronomers sometimes describe the Milky Way's gravitational reach as a conversation rather than a command. Its halo extends far beyond the visible disk, guiding the paths of its companions with patience. The smaller galaxies circle like moths around a lantern, drawn but not burned. When they finally merge, their motion is absorbed into a new order, their orbits becoming part of the galaxy's larger rhythm. What looks like solitude from Earth is actually kinship, the Milky Way, surrounded by faint siblings moving in long, slow embraces. The stars of the Sagittarius stream, visible only through precise measurement, tell this story in their motion. They form an arc that nearly encircles the sky, crossing the galactic plane at multiple points. Their paths trace the spiral of surrender, showing how a smaller system dissolves gracefully into a greater one. Each star continues its orbit, but now under the Milky Way's unified gravity. The merging process transforms two identities into one coherence. It is cosmic empathy enacted through physics. Even collisions with small gas clouds and star clusters follow this peaceful script. When such material enters the galactic disk, it rarely causes upheaval. Instead, it triggers localized bursts of star formation, small celebrations of renewal that fade into equilibrium. The Milky Way's magnetic field and dark matter halo distribute the energy of impact evenly, preventing destruction. Every addition becomes nourishment. The galaxy's serenity is a form of resilience, an ability to turn disruption into harmony. This quiet evolution extends beyond the visible stars. Streams of dark matter, invisible rivers of gravity, likely flow through the Milky Way, connecting it to the cosmic web that spans the universe. Through these currents, the galaxy exchanges energy with its environment, receiving subtle infusions of matter over eons. Even at this scale, the process is patient, continuous, and balanced. The galaxy grows the way a tree does, by drawing from its surroundings without disturbing them. To imagine these mergers and streams is to see the Milky Way not as a fortress but as a host. Its peace is inclusive, not defensive. The stars that once belonged elsewhere now illuminate our sky. The gas of vanished galaxies fuels the birth of new suns. Every visitor becomes family. In this way, the galaxy teaches that harmony is not achieved by resisting change, but by absorbing it. The universe is not a battlefield of separate entities, but a web of continuities. On Earth, the night sky hides all this slow choreography. The Magellanic Clouds appear serene, the arc of the Milky Way unbroken. But behind that stillness, gravity is at work, weaving new connections, reshaping the map of stars one patient gesture at a time. The galaxy remains calm because it has learned the art of assimilation. Even the arrivals at its gate, those wandering galaxies drawn from afar, find not violence, but welcome. The Milky Way grows by receiving, and in doing so, it keeps its light soft. Over time, even the most serene structures must change. The Milky Way, though it glows with ancient calm, is not frozen in eternity. It lives through cycles that span billions of years, slow rhythms that shape its temperature, thickness, and motion. Like a living organism, it experiences seasons not of weather, but of energy and form. These billion-year seasons are the galaxy's quiet heartbeat, pulsing so gradually that no civilization could ever feel the shift. Yet through them, the Milky Way maintains its balance, renewing itself without surrendering its composure. Astronomers call this process secular evolution, the slow internal transformation of a galaxy through its own gravity, rotation, and feedback. It is evolution without catastrophe, change without collapse. Over eons, stars scatter slightly, gas flows inward, and angular momentum drifts outward. The bar at the galaxy's center thickens and slows, the spiral arms adjust their spacing, and the disk subtly reshapes itself. None of these motions are dramatic, yet together they amount to metamorphosis. The galaxy ages the way a coastline erodes imperceptibly, but completely. At the heart of this slow transformation is heating, not of temperature but of motion. As stars orbit the galaxy, gravitational encounters tiny, persistent tugs from clouds, spiral waves, or passing companions gradually increase their random velocities. Young stars move in smooth, thin layers close to the galactic plane. Older ones wander farther above and below it, forming what astronomers call the thick disk. This thickening is the galaxy's equivalent of wrinkles, a visible memory of time. It does not signal decay but maturity. Each generation of stars carries the record of countless interactions, and their dispersion keeps the system dynamically stable. The gas that fills the disk also follows this rhythm. Over millions of years, it circulates between hot and cold phases, cycling through birth and rest. Supernovae heat it, radiation cools it, gravity gathers it back into clouds. The balance between these phases defines how actively the galaxy forms new stars. When supernova activity increases, the disk warms and expands, pausing creation. When it quiets, cooling resumes, allowing new stars to emerge. The Milky Way's long-term serenity arises from this feedback, a galactic thermostat that prevents extremes. Even the spiral arms drift through their own life cycle. They are born from instabilities in the disk, grow strong as waves of density, and then fade as energy dissipates. Over time, new patterns replace old ones, each generation of arms reshaping the flow of stars and gas. This process is slow enough that a spiral can last for hundreds of millions of years before dissolving. To an observer on Earth, the change would be invisible, yet it ensures that the galaxy never stagnates. Motion gives it form gives it grace. The galactic bar, that elongated core of stars, also evolves in measured time. It transfers angular momentum from the inner regions to the outer disk, gradually redistributing energy. As this happens, the bar lengthens and slows, altering the paths of stars near the center. The process is self-regulating. The bar grows until it reaches equilibrium, then stabilizes again. This subtle shifting keeps the Milky Way's inner architecture alive, like the slow breathing of a creature resting in deep sleep. In the outer reaches, the halo records the memory of everything the galaxy has encountered. Stellar streams and remnants of ancient mergers drift there, their orbits slowly mixing into the general field. These features will eventually fade, dissolved by time and gravitational blending, leaving behind a smoother halo of stars. The galaxy's edges are where its history is erased, where turbulence becomes calm again. Every irregularity, every ripple is absorbed into uniformity. The halo is the galaxy's archive and its horizon, a border where motion dissolves into stillness. Beyond the halo, the Milky Way interacts with the larger environment of the local group, a small family of galaxies bound by mutual gravity. The Andromeda Galaxy, its great counterpart, approaches at a gentle pace about 100 kilometers per second. In 4 or 5 billion years, the two will meet, merging into a single, larger system. It will be a slow encounter, unfolding over billions of years, more ballet than collision. Their stars will weave together, forming new shapes, perhaps an elliptical galaxy glowing quietly in the twilight of the universe. Even that grand merger will preserve the pattern of serenity, proof that cosmic unions need not destroy. Throughout these billion-year seasons, the Milky Way maintains its equilibrium by conserving angular momentum. As gas flows inward, stars migrate outward. As some regions warm, others cool. The total energy remains balanced. This conservation acts like a moral law of motion, a principle of fairness written into physics. Nothing in the galaxy gains without something yielding, and nothing yields without something renewed. The Milky Way's peace is therefore not static, but just each motion countered, each disturbance repaid with calm. The chemistry of the galaxy also evolves in these slow rhythms. Each generation of stars enriches the interstellar medium, with heavier elements forged in their cores. Over time, the metallicity of the disk increases, giving rise to planets, atmospheres, and complex molecules. This steady enrichment parallels the physical evolution of the structure itself. The galaxy becomes both denser and more hospitable to life, its inner equilibrium mirrored by chemical generosity. The stars are not just lights, they are alchemists, patient builders of harmony from the raw material of hydrogen. In the far future, when most of the interstellar gas is gone and star formation dwindles, the Milky Way will enter a long winter. The remaining stars will drift apart more slowly, their light reddening as they age. Yet this too will be peaceful. The galaxy's decline will not be a fall but a rest, a descent into quiet after an era of continuous creation. The spiral arms will fade, the bar will blur, and the disk will thicken into a soft, diffuse glow. The Milky Way will become a relic of order, floating serenely in a darker sky. To glimpse this distant fate is to understand that serenity does not mean permanence. The Milky Way's peace exists precisely because it changes. Its stability is a performance sustained by motion, its beauty, a product of age and adaptation. Like all living systems, it endures by adjusting, not by resisting. Even in its eventual fading, there will be dignity, a slow dimming of the grand design into something gentler, simpler, and still. The galaxy's billion-year seasons remind us that calm is not the opposite of time, but its companion. Every ripple that crosses the Milky Way's disk is an expression of that companionship, a slow rhythm that carries light through eternity. The universe ages not in silence but in song, and the Milky Way is its longest note, a hymn to balance sung across the endless night. To understand the Milky Way's peace, astronomers must first try to disturb it. They build machines that can measure its faintest tremors, telescopes that can see through dust, and satellites that can watch the invisible. Science tests serenity by pressing upon it, by asking the galaxy to reveal how its calm survives. From orbiting observatories to deep radio arrays on Earth, every instrument becomes a question cast into the dark. Is this stillness real, or only an illusion of distance? The great cartographer of this age is Gaia, a satellite that watches over 1 billion stars at once, measuring their positions, distances, and motions with precision finer than a blink of light. Through Gaia's data, astronomers have built the most complete map of the Milky Way ever made, a living atlas of motion. What appeared fixed to the naked eye now swirls with hidden tides. They see the disk ripple like a pond touched by an unseen hand, evidence of gravitational disturbances from past encounters, yet the overall pattern holds. The spiral arms remain coherent, the bar turns smoothly. Every small imbalance is absorbed into a larger equilibrium. The more Gaia sees, the more astonishing the galaxy's steadiness becomes. In radio wavelengths, telescopes like ALMA in Chile and the Very Large Array in New Mexico trace the cold hydrogen that forms the galaxy's skeleton. These observations show the slow movement of gas through the arms, the gentle compression that forms stars, and the faint bridges of material connecting the disk to the halo. Even the smallest details, tiny filaments, only light years across, align with the grand rotation. It is as if the galaxy's every atom knows its place in the pattern. When scientists model these flows on supercomputers, they discover something elegant. Stability does not require perfection, only balance. A galaxy can breathe and bend, flare and tremble, and still return to calm. Infrared telescopes, free from the interference of dust, peer into the obscured core. They reveal star clusters orbiting in elegant ellipses, streams of gas spiraling toward the central black hole, and the glowing threads of the galactic bar. From these images, researchers reconstruct the bar's rhythm, its slow rotation like the pendulum of a cosmic clock. Each discovery refines the model, showing how gravity, dark matter, and feedback maintain equilibrium. The deeper the scrutiny, the stronger the evidence that serenity is the galaxy's natural state. Meanwhile, X-ray and gamma-ray observatories record the galaxy's high-energy events, supernova remnants, pulsars, and jets from Sagittarius A*. These instruments expose the Milky Way's quiet power, revealing its capacity to endure bursts of energy without losing form. Even explosions on stellar scales cannot unseat the disk's composure. The surrounding medium absorbs the shock, redistributes the energy, and resumes its motion. What looks like fragility is resilience disguised as grace. Every wavelength adds a new layer to the portrait. Ultraviolet eyes capture young, hot stars. Optical surveys count billions of older suns. Radio detectors follow the coldest gas. Gravitational simulations test their relationships. Together, they form a single truth. The Milky Way's calm is measurable, but not simple. It is the product of constant motion constrained by ancient laws. The peace we see above is not stillness frozen in time, it is equilibrium maintained by feedback, by subtle exchanges of energy and momentum. Even now, scientists use time-domain astronomy to watch the galaxy change in real time. Variable stars pulse like metronomes, tracing the tempo of their surroundings. Flares from the black hole at the center rise and fall with quiet regularity. Cosmic rays surge, fade, and surge again. The Milky Way's serenity is dynamic, a film in motion rather than a photograph. Each observation refines the understanding that peace and activity are not opposites, but partners. Artificial intelligence and numerical modeling now simulate billions of stars interacting under gravity, magnetism, and gas dynamics. When scientists allow these models to evolve, galaxies emerge spontaneously. Disks form, spiral arms appear, and feedback stabilizes them, no human hand required. The simulated galaxies look astonishingly like the Milky Way. From chaos, order arises naturally. The implication is profound. Calmness is not rare but fundamental. Given enough time, the universe arranges itself into harmony. The Milky Way also reveals its quiet through vibration. When passing satellite galaxies tug on its disk, waves ripple through the stars. These vertical oscillations can be detected by careful mapping of stellar velocities. Some scientists liken them to the ringing of a bell struck softly by cosmic hands. The amplitude is small, the frequency low, but the motion is real. The galaxy rings, yet never breaks. This resonance may be how it redistributes energy after encounters, keeping its symmetry intact. Radio astronomers have traced magnetic loops rising above the galactic plane, ghostly filaments glowing faintly with polarized light. These structures connect the disk to the halo, forming conduits for energy exchange. The magnetic field lines twist but do not snap, flexing to accommodate pressure. Such flexibility keeps the galaxy from tearing itself apart. Even invisible forces move in courtesy, bending rather than clashing. Testing the Milky Way's peace has also required patience on human timescales. Decades of observation reveal changes so small they border on the philosophical. A gas cloud shifts a fraction of a light year. A supernova remnant cools. A stream of stars drifts slightly from its modeled path. Yet these tiny details confirm the same conclusion. The system holds. Gravity, magnetism, and motion collaborate in ways that sustain the whole. The closer one looks, the more one sees design without designer order, arising from the simplest of laws repeated for eons. The galaxy's balance is now studied not only as a cosmic curiosity, but as a template for stability. Physicists use it to understand self-regulating systems, mathematicians to model complexity that resists chaos, and philosophers to contemplate how harmony emerges from entropy. The Milky Way, once an image of wonder, has become a symbol of persistence. It demonstrates that peace need not be passive, it can be active, maintained by continual adjustment, guided by quiet intelligence woven into nature itself. And still, after centuries of mapping and measuring, the night sky looks the same. The band of stars arches unchanged across the heavens. The data may grow richer, the theories more intricate, but the human response remains ancient awe. Every telescope, every equation, every simulation eventually leads back to the same realization that the galaxy's tranquility is real, but it is also delicate, earned, and ongoing. Science does not diminish the mystery, it verifies it. The Milky Way endures inspection as serenely as it endures time. Instruments can dissect its light, chart its motion, and even glimpse its dark heart, yet none of these disturb its essence. The peace of the galaxy survives every measurement. It is not a facade but a truth, that the universe, left to its own patience, finds balance. The Milky Way has been proving this for billions of years, and through every test, it continues to hum its long, soft note into eternity. At the end of all measurements and theories, what remains is a feeling. The Milky Way stretches across the sky like a thought too large for language, and the mind, small but awake, tries to follow it. The galaxy's calm cannot be touched or owned, it can only be witnessed. In that witnessing lies something profoundly human, a need to find order in motion, to sense meaning in silence. The stars do not speak, yet they convey a philosophy older than words, that peace is not the absence of activity, but its perfect expression. Every part of the Milky Way participates in that quiet philosophy. The black hole at its center, massive and patient, rules through stillness. The spiral arms, woven from billions of suns, rotate in unhurried grace. Dust clouds absorb light so that softer forms may appear. Even dark matter, invisible yet essential, holds everything in its unseen embrace. The galaxy is not a single object, but a balance of contradictions: gravity and light, motion and rest, birth and death, all coexisting without conflict. Its peace is not imposed, it is cultivated. When the first humans looked upward, they had no instruments, no mathematics, only wonder. They saw the Milky Way as a bridge to the divine, a river where souls crossed from one world to another. Though the myths have changed, the emotion has not. We still stand beneath the same ribbon of light, aware of its vastness, comforted by its constancy. To fall asleep under the stars is to return to that first astonishment, to remember that even in an expanding universe, something endures. Science, in its precision, has not taken the poetry from this truth, it has deepened it. To know that every photon arriving at the eye has travelled for thousands of years, to know that every star has its own story of fusion and decay, is to understand peace not as ignorance but as comprehension. The Milky Way's serenity becomes more moving when one knows the effort behind it, the equilibrium of forces, the dialogue between matter and void, the restraint of energies that could so easily rage. Its harmony is not fragile, it is earned through balance. In this light, the galaxy becomes a teacher. It shows that calm is not found in escape from complexity, but in its mastery. The Milky Way is busy beyond imagination, stars forming, gas swirling, dark matter flexing, radiation flowing, yet from this constant motion emerges coherence. If one listens closely, one can almost sense the rhythm of its pulse, slow and immense, like the breathing of space itself. It is a lesson written across the heavens, that stillness is not the opposite of motion, but motion perfected. The philosophical quiet of the Milky Way also invites reflection on the fleetingness of human life. Every moment of existence happens within one rotation of a small planet around a modest star, which itself is one of hundreds of billions. Yet insignificance, viewed rightly, becomes liberation. The galaxy does not diminish human meaning, it expands it. To belong to such immensity is to be woven into the universe's own fabric of endurance. The peace above is not foreign, it is shared. In the galaxy's design, one sees echoes of human aspiration. Just as the spiral arms sustain form through balance, so does the mind seek order in experience. Just as stars exchange matter through life and death, so do generations pass wisdom and memory. The same equilibrium that preserves the Milky Way exists, in miniature, in thought, in love, in art, the instinct to align chaos into meaning. When we gaze at the night sky, we are not merely observers, we are participants in its symmetry. Eventually, long after the last observer is gone, the Milky Way will merge with Andromeda. The familiar shape will change, the spiral will dissolve, and the stars will rearrange into a new equilibrium. Yet even then, peace will not end, it will transform. The laws that sustain harmony now will continue to guide that future galaxy, just as they did at the beginning. The light may fade, but the principle of balance will remain, humming through the dark, patient as ever. For now, though, the Milky Way remains what it has always been, a river of light flowing across the dark shore of the universe, steady and calm. Beneath it, the earth turns, and life breathes, and dreams unfold. The stars do not hurry. They remind us that time can be generous. Each one burns in quiet affirmation that the universe, though vast, is not indifferent, it is precise, deliberate, and, in its own way, kind. To fall asleep beneath the Milky Way is to rest inside that kindness. The night becomes a cathedral, its ceiling painted with motion so slow it feels eternal. The body relaxes into gravity's cradle, the mind drifts towards stillness, and the heartbeat seems to join the rhythm of the galaxy itself. The peace one feels is not illusion, it is resonance. The same forces that hold the stars hold the sleeper. The same balance that sustains the spiral sustains the breath. The galaxy does not whisper promises, it simply exists in patience. Its light, arriving after journeys longer than civilizations, touches the skin as softly as thought. And in that touch lies the most peaceful truth of all, that we too are part of this harmony, brief notes in an endless symphony, sung by a universe that has learned the art of quiet endurance. Night falls again, and the earth turns quietly beneath its canopy of stars. The Milky Way arches above like a bridge of memory, carrying the light of billions of suns across oceans of silence. It does not ask to be understood, only seen. Its beauty is not performance but presence. It has watched worlds rise and vanish, and still it flows, unbroken, through the dark. Every star, is an act of patience. Every cloud of dust, a moment of rest. In the galaxy's slow breathing, one can almost hear the rhythm of time itself, steady, impartial, kind. There are no edges here, no boundaries between past and future. Only the soft blending of motion into stillness, the quiet exchange between gravity and grace. Somewhere within this vast calm, a small planet spins, its oceans reflecting the same light that left those distant suns long before life began. The Milky Way carries those reflections back, folding the moment into eternity. Beneath its river of light, every heart finds an echo, every thought finds a place to rest. To sleep under its glow is to return to origin, to float for a while in the peace that existed before sound, before thought, before the first dawn. The galaxy hums not of distance, but of belonging. Its serenity is a mirror of the universe's oldest truth, that order is born from motion and silence from song. And when the eyes close, the Milky Way remains not as an image, but as a rhythm within the body, a memory older than memory, the gentle pulse of everything that ever was. The night holds its breath. The galaxy turns, and peace, endless and unbroken, continues to unfold across the dark.